So this is the video associated with the kinetics or the clock reaction station that you did on our A-level days. If anyone's watching this who didn't come to the A-level days, no big deal. All we're doing is just working through three aspects of a clock reaction. The first one that will be the rest of this particular video is a demonstration in which we just show how for the clock reaction the concentration of the colored species changes as the reaction goes along. And then in part two, which is a different video, we go to the typical clock reaction, the one in which nothing happens and then suddenly it turns blue, using that to get the rate law. And then in a third video, using that to study the Arrhenius relationship and determine the activation energy for that particular reaction. So like I say, hopefully of use to those who did the A-level days, and possibly even of use to those who didn't do the A-level days. So a clock reaction is typically one in which iodine is produced. Now here I'm being particularly anal. You're more used to seeing this in terms of 2I- goes to I2. The actual species that is in solution is the triiodide anion, which is of course just essentially an iodine molecule, I2, with an extra iodide stuck on it. But there's no point in us being naughty and not telling the whole truth. Now the reason why I've got the triiodide anion in that sort of orangey brownish color is because if it's iodine with an iodide stuck on it, then it's going to have that orangey color that iodine has. And that's one of the things that we can use for studying the clock reaction. So if we start off with our components that we mix together, solution of iodide, usually potassium iodide, with hydrogen peroxide and a little bit of acid in there, then it's a colorless mixture. As soon as we mix them together, though, they can start reacting and start to make the triiodide. And so what you find is it goes a little bit yellow, and then a little bit yellower, so orangey, and then a little bit orangier, and then finally up to that orangey brown type color. Okay. Now you're told in your A-levels that you can follow chemical reactions in order to determine the rate by seeing what happens to various factors associated with the reaction as you go through. So pH is one of those. You can have a mass change if there's a gas involved. You can have a volume change if there's a gas involved. And of course, one of the cute ones is color. And that's exactly what we can do here. We start off at colorless and we end up with this sort of orangey brown solution. So if we plot out time against the absorbance, in other words, how many photons that particular color absorbs, then we see a curve like this. And in the A-level days, you actually used our little spectrophotometers, which is a fancy name for a fancy colorimeter, to study this. And so you measure the absorbance. You can relate in ways that we're not going to talk about today, but you can come in and do an experiment in a lab that shows this. You can relate the absorbance to the concentration of the triiodide. And so what we are doing here is we are using color in order to determine the concentration against time, and so thereby we can start generating the rate of the reaction and so forth. More complicated calculations than you do at A-level, but a cute little demonstration for you.